Okay, let's get started. So just a quick roadmap, homework 4, the visit counting cookie, you have everything you need to be able to do that. Objective 1 is completely on the table right now, and today we want to talk about Objective 2, authentication. I guess just authentication, and Friday's lecture is going to be the AND tokens, which I can tell you, I'll briefly talk about tokens today. There's not a whole lot to it in addition to authentication, but there are implications that I want to talk about next time. Authenticated chat also. Once we have Objective 2, so by Friday, you'll be able to do Objective 3 as well. Authenticated cross-site request forgery tokens. I'm not really going to have lecture content specifically about this. Maybe I'll revisit the objective and talk about it a little bit. But once you have authentication and user accounts in your database, when you create cross-site request forgery tokens, we can strengthen those. Like in homework 2, we didn't have like really secure cross-site request forgery tokens, but now we can because we're going to associate them with a particular user, the user that requested the page, and create a token just for them. So now the attacker can't just get valid tokens at their leisure because they won't be logged in as that particular user. So we get a form request for a particular user, but it doesn't have their cross-site request forgery token. It's not legit. So now the attacker can't spoof that. And finally, HTTPS, that's going to take like all of next week to talk about. HTTPS is similar in structure for like the lecture and homework to the WebRTC stuff, where I'm going to spend a week talking about it in lecture, and then it's not overly complicated when you set it up in your program, but it can be tricky. Or if you fully understand what's going on, it can be really easy as well. But it does take a week of background to talk about. I got to talk about encryption first. If I'm going to talk about HTTPS, what is encryption even, and a whole bunch of other topics. So that's our roadmap. That's where we're at for the homework. So right now you can do Objective 1, and by Friday you'll can do Objectives 2, 3, and 4. So just like homework 3, there's no reason to not get started early. You have most of the content you need to complete most of the homework 3 weeks before the deadline. So you have plenty of time, ample time, to do the homework, though I haven't been seeing stellar time management skills from this class, so it is what it is. But you have the ability to start these homeworks ridiculously early. 4 weeks before the deadline, you can start Objective 1 on each homework. So anyway, let's teach you how to do this stuff. Hi, Cole. Can name one reason for what? I forgot what I said now at 3:02. I haven't started homework 3, but I appreciate the sentiment nonetheless. I mean, if you can start late and get things done, I never care about that. Like, you do you. It's when students start late and then ask me for extensions. That's the stuff that bothers me. Like, you had 4 weeks. It's not my fault that you started right at the deadline. I had a ridiculous amount of extension requests for homework 2. Not absurd, but I mean, it's probably at least 5% of the class. Like, asking for extensions on it. Like, just start early and manage your time. Some of them had like doctor's notes, and that's legit and stuff, but there were a lot of really bad excuses too. Homework 3 is out. Damn it, Cole. Yeah, you should pretty much be done with homework 3 by now. To be serious for a moment. You should be wrapping up homework 3 by now. It's due Monday. Yeah, it's due Monday, so you should be pretty much wrapping that up at this point. If you're not, just putting the finishing touches on your homework 3 homework. You're behind my expectation of where you should be. Because that really throws you off. I know a lot of you do this, but I don't know how you really pull that off. Mainly because I know a lot of you aren't, because I've seen the grades. But, or why you're pulling that off. Because I'm teaching homework 4 content. Like, this is the time where your brain should be shifting to homework 4 and getting started on that. Because what I see is a lot of you wait until, and maybe this is course design, maybe there's something I can change in the structure to address this. But for this whole first week of homework 4 content, you're all still thinking about homework 3. And then by the time you start homework 4, you're at least a whole week of lecture behind. And you're probably not going to think about 312 at all next week, if I know how students work. So that's 2 full weeks of lecture that you're just kind of not thinking about until homework 4 is due, and then you do it all at the same time. If there's something I can change in the course, by the way, that could mitigate that, I try to just play into human nature and try to get things designed in a way that just plays into that. I haven't figured a good way to do that in 312, but if you can think of something. I can't think of anything except just having the deadlines earlier and giving you less time after the content ends. But anyway, I'm rambling. I'm just thinking out loud. But any suggestions would be... Unfortunately, there's other classes than 312, but you have 4 weeks per homework, is my counter to that. Right? No, that's not right. 3 weeks per homework. Well, because one's due. You can start the homework up to 4 weeks ahead of time. But technically you have 3 weeks with no other homework on the table. So there are other classes, but that should be enough time for you to manage around other classes. I also don't have a midterm. I don't like hearing stuff like that because I don't have a midterm. I have 4 homeworks and the project. It should be a little easier to manage 312 around your other classes, or vice versa. Yeah, and then there's that. I wish I could spend my time on it, but I can't. Yeah, that one is tougher. Burnout, that's the correct answer. At this point in the semester, I understand, because we're all burnt out. I'm exhausted, too, at this point in the semester. But for this is an issue at homework 1 as well. Every semester, it always is. 341 got pre-lab, lab, post-lab, homework, books, and project. So I should have more things due, is what you're saying. I hear you. Just have more things due in 312. I know that's the complete opposite of what you're saying, but if I had all that stuff due, then you would tell your other professors, oh, I got so much 312 work to do, I have to ignore your class. And then I would just steal your time. Jesse wants to be redacted too. Yeah, I got to stop. Thank you for reminding me of that, Priest. I don't think I'm logged into Piazza, though. Actually, I got to switch real quick because it'll leak all of your email addresses. Yeah, I mean, it is what it is. I don't mean to really rant on that. Because I know you all have a lot on your plate. I try to be fair in my course design, and then to still see a lot of really bad grades and stuff. It's just kind of sad, because I want you to see you all do well. And there's not much more I can give on my side. So I don't know what else to look at. I'm more looking for ideas of what to do. I clicked the wrong thing. What am I looking at? So on the other side of that, speaking of give, so I do have the course eval incentive posted. The course evals are not upon us yet. They're not released. I don't believe so. I don't always check the mass emails that I get sent. But course eval incentives, I want to get these out because the resignation deadline is Friday. I didn't confirm that, but I was told it's Friday, which I believed. So I wanted to get this out there so you can know what to expect, because some of you are making that big decision of whether or not to resign the course. So I at least want this out there so you know what you can do to recover your grades. So the incentive, 60, 70, or 80%, 1, 2, or 3 objectives that you can make up. So this is a little different. If you ever heard how I did my stuff in previous semesters, it's a little different. Is you can resubmit any old homework and then tell me which objective you want regraded on that homework. So if we hit 80%, which historically we get pretty high response rates in 312, so 80% is not out of the question. I think I had 90 as an incentive before, and we actually hit the 90 incentive. So whatever the top incentive usually does get hit historically in this class. Not that you can count on that and rely on that, but just to give you a heads up that I would at least expect 1 or 2 to be met. And then you let me know which objective you want regraded. Make a submission. I'll have special submissions in Autolab. And you say, I submitted homework 1. I want homework 1, objective 3 to be regraded. And then you can get your a regrade for that objective. So up to 3 if we hit the response rate of 80, up to 3 objectives. So if there's an entire homework where you just completely didn't do anything, didn't do well on, and we hit the 80% incentive, you can do that homework, resubmit, and ask for regrades on objectives 1, 2, and 3, and get up to a 70 on that homework, even if you initially had a 0 on that homework. So those of you who did miss the deadline or whatever, and didn't have a doctor's note or anything or any excuse that I accepted, you can still get a 70 of those objectives. And I believe mathematically this would mean everybody can still pass, even if you've done absolutely nothing all semester. I believe that would be the case. I didn't run the numbers, though. Yeah. If you have a 90%? Oh, I'm not going to have a 90% objective. I almost made this 70, 80, 90, and that would have been the 90, and I slid it back by 10%. So I'm not going to add another incentive for 90. Unless you want to propose something. I've done this before. I asked the class to propose some. If you want to propose something for a 90% incentive, as long as it's not related to grades, I'm not going to add more, and then the hands go down. As long as it's not related to grades, or if it is, I mean, I can always say no. Yes, just tell me what it is. God, no. No, I'm not dropping a whole homework. There's only 4 homeworks. That's 15% of your entire grade. No, I'm not dropping a homework because you're not going to do homework 4. No, not dropping a whole homework. That's never going to happen. I'm not dropping even objectives this time. 4 objectives at 90%? No, I did think about that. I'm not going to 4. Like waive lecture questions? I mean, I already waived 20% of those, don't I? 10%? 10% of them will be dropped. Yeah, I might do some lecture question stuff. Why don't you post on that Piazza post some suggestions down here, and I might add a 90%. Oh, I can't scroll down. I did it anyway. God damn, Piazza. Piazza has a way to view, so I can be in student view. The problem is if you post anonymously, I can still see your name, so I have to be very careful going to Piazza during lecture. They have a student view where it hides everybody's name, but as soon as you click on another post, it forgets that I wanted to be in student mode and then shows everything again. So I have no good way of hiding it. So I can't really scroll down. I think those were posted not anonymously, but I can't really navigate around Piazza right now. But post on that post. I'll take a look at your suggestions. Maybe I'll add a 90% that gives some lecture questions or something. I don't know. I'll look over your suggestions. I don't want to go further than 3 objectives, though. I thought about that for a long time. So I did one semester. I was dropping objectives, and I went all the way up to 90% was 4 objectives. And there were some students who did not learn what they were supposed to in this class who ended up getting decent grades. And I looked at that like the student just gamed the whole system the whole time. And I wasn't thrilled about that. But 3 objectives, that was when all objectives were equally weighted as well. So 3 objectives when the first 3 objectives of each homework are, I misspoke, didn't I? First 3 objectives are 80% of that homework grade. So you can get 80% of the grade, even on a homework that you didn't even submit. But you do have to do that homework. So I don't want to go further than 80% that you can make up. Or if you make up like objective 1 on all 3 homework assignments, it's a significant boost in your grade. So I don't want to go further than that, or else, I don't know, it becomes, at a certain point, becomes unfair to the students who did do everything on time. Type a script to fill out the course eval. How has nobody done that before? I didn't even think of that. I should write the script and just give it to you and say, click this link. That's all you have to do. But I've had people suggest non-grade related, I already downloaded this. Non-grade related things in the past, which I had fun with. I forget what it was even, but. What am I doing? Yeah, I'm not. I mean, if you want to say pizza party at 100%, I'd be fine with that. What am I doing here? Oh, I was hitting the wrong button. That's what I was doing. Okay, let's get into some slides. Free HBO Max subscriptions. 90% for me to wear a costume during lecture. I already wore a costume. I wouldn't mind doing it again, I guess. All right, so let's talk about authentication. Man, speaking of exhaustion. So we want to build user accounts. This is a feature that you're used to all over the internet. You use user accounts constantly. We want to build that. Let's build that. You know what a user account is? It's going to essentially be a way to serve customized content to each user and also authenticate the requests and information that they send you so you can be reasonably assured that that content did come from that particular user, or at the very least that particular account. We do that in 2 steps, registration and authentication or login. Authentication, the user is going to provide you with their credentials, their username and password for how we're going to build it in the homework. Obviously, depending on what you're signing up for, they'll ask for more information. For this, we want username, password. That's what we want. So that's when they register, and then to authenticate, give me the same username, password, and you're authenticated. We're used to this from the user end. No surprises here. We've all used things like this. At the very least, you use MyUB and UB email and stuff like that. I can guarantee that, at the very least. Registration forms look like this, and usually I should just get rid of this slide because I'm like, this is what verification is. But I do want to talk about the email verification. A lot of times you have to verify your email when you sign up for an account. This is increasingly common these days. You sign up for an account, it says we send an email to you, and then you have a link in that email, you click the link, and then your account is activated or not authenticated, verified, that you actually have that email address, that account is associated with a valid working email address that's capable of receiving an email. You have access to that email account. It's a very nice security measure. I want to talk briefly about why, because I already told this story earlier in the semester, but I had those bots that were creating thousands, tens of thousands of accounts on my system that one time. When that happens, that didn't have too much adverse effect to my app because I had email verification on. I had it set up so you had to have a buffalo.edu email address to sign up for the service, so I only had students in there. All the random bot accounts that were hitting my registration form were randomly generating email addresses which were obviously fake email addresses. They weren't actually creating email address accounts for every single fake account that they were creating on my app. So it hit my email verification. My app says, we sent you an email. and the bot can't check that email because it went to a fake email address. So it shuts those bots down. If you verify email, it really shuts those bots down. They can't just absolutely bombard your app with crap and ads and all that stuff. Now, they can set up an email account and have that actually work. A very sophisticated botter, which I wonder why they didn't do this, probably because it would give them their identities away. But they could automate the process of creating email addresses and then actually attack you with bots with email verification. They don't do that. I would guess that it would give them a way like Gmail or a service probably wouldn't let you automate that process, that sign-up process, that they'd have some captchas and stuff like that. And if they have their own server creating their own email addresses, that's going to give away who they are. So I imagine that's why they aren't that sophisticated. But verifying an email is going to really slow down those bots. So when you see that, that's usually what's going on. And it is a stronger form of identification. They know you have access to that email address, that email account. So on the server, we want to store your username and password. You give me your username and password, I'm going to store that in a database, and I'm going to store that for safekeeping so when you log in, I can check. I can look up in that database for this username, what's the password, check if the passwords match. If they match, you're in. If they don't match, you're not in. And those passwords have to match exactly. We're used to that, again, from the user side. But the big question is, what happens when that database is compromised? I got this database full of passwords. Somebody hits me with a SQL injection attack and gets all those passwords. Or even less malicious than that, I got a rogue dev on my team, or more malicious. I got a rogue dev on my team, and my devs have access to the database. Or at the very least, the sysadmin is going to have access to to that database. Somebody has to have access to that database, at least the sysadmin. What if they just steal everybody's passwords? What if some database manager at a social media site just decides to take some celebrity's password, log in as them, and then make some bad tweets, unassuming tweets? We don't want that to happen, ever. So never, ever, ever, this is one of them never, ever, ever things. Never store passwords as plain text. Never just store a password anywhere. Not just a database, maybe have a text file. I don't care what it is. Never store that password in plain text. Of your users, of course. If you're storing your own passwords in plain text, you do you. But don't store your users' passwords of your app in plain text ever. Do not do it. And this gives us what we want of even those sysadmins. We don't want them even knowing your password. They shouldn't know your password. Ken Smith does not know your UBIT password. When you log into Timberlake or anything, he doesn't know those passwords. He can't. He can't access those. That's the type of security we want, and we're going to do that by hashing. A lot of temp emails don't require identity, but do those temp emails have CAPTCHAs when you create them? They have to have some line of defense to stop the bots, or else every bot would use those. I would suspect, anyway. I am speculating quite a bit when I say that. So we want to hash those passwords and then just store a hash of the password. That's what we want. That's the feature we want. So we're going to pull out a hash function. Hash functions are functions with certain properties, usually fixed length. You have a hash function, you put anything into the hash function, and what comes out has some fixed length, fixed number of bytes or bits or anything. Usually used for certain applications like hash tables. For hash tables, you need a fixed length hash, or not necessarily fixed length, but some maximum value which will imply fixed length. So when you have a hash table of size 1,000,000, and you take some value you want to store, you put it in your hash function, well, that value better be between 0 and 999,999. Like, it needs to be in that range for your indices of your hash table. So you need a hash function that's going to map to a valid index of your hash table. So we have certain properties of hash functions that we like, that we have for certain applications. Hash functions do not add any security. Misconception number 1 of this lecture, of 2. There are only going to be 2. But hash functions do not add, or might not add any security at all. Just because you hash something does not mean that it's secure. To get any level of security at all, you need what's called a cryptographic hash function. Not all hash functions are cryptographic hash functions. So if you take that hash function you use for your hash table and hash passwords using that, you're most likely, I'll say, not going to get an ounce of security out of that thing because that hash function might be reversible. You don't want to use that, and with the hash table specifically, you're going to have a lot of hash collisions just by design. Like you're going to have hash collisions, and that's going to make it very easy for somebody to break your passwords. Cryptographic hash functions, which I'll just call hash functions for the rest of lecture. When I say hash function, I'll mean cryptographic hash function, but that's not true in general. These are meant to be one-way functions where you compute the hash of a value. You get this hash. But if you're given the hash, you can't go backwards. You can't compute the input that produced that hash. This is what we want when we're storing passwords. We're going to hash the password and store just the hash of the password. Ken Smith could totally figure out your passwords if you wanted to. If you have a weak password, which is what we're going to talk about. Depends what your password is. Ken Smith could figure it out. If you have a 20-character randomly generated password, he's never figuring that out. He'll never know, no matter how much he tries. So for cryptographic hash functions, I'm going to use SHA-256. That's going to be my hash function of choice for lecture to show you what hash functions are. So if we go to the site, and I want to hash password, hash it. This 5E884 blah, blah, blah. 5E884 blah, blah, blah. This is the actual SHA-256 hash of the string password. So if your password is password, that's going to be your hash. If SHA-256 is the hash function being used, which it is pretty commonly used still. It's getting older. It's showing some age. SHA-3 is out. But SHA-256 is still out there. There are theoretical attacks, but no practical attacks on SHA-256 yet. SHA-256 uses a whole bunch of bit-level stuff and shuffles around the bytes of your input, goes multiple rounds through this somewhat circuitry, goes through this, through it again, through it again, through it again, some number of rounds, I don't remember how many, and then whatever comes out of that last round, that's the hash. The way this is set up makes it very difficult to go backwards through this thing, and nobody's found a practical way to go backwards. At least if they have, they're not telling anyone about it, and they're just out there breaking stuff. A lot of this works on bit-level operations. These are extremely efficient, extremely fast. Most of these operations are part of the instruction set of your CPU itself. These are taking one clock cycle each to compute. Very, very efficient, which is something we want out of our hash functions. We want it to be very fast to compute. Not always what we want. I can talk about that too. We don't always want it super efficient, but usually we want that to be pretty efficient. I might as well talk about that since I mentioned it. Sometimes we don't want our hash functions to be efficient. Sometimes we want them to be slow, so it's harder to attack the hash function. But in general, we usually like things being fast. Better call Saul. So there's one big problem with this. So you can't go backwards. If I give you a hash of a password, you can't go backwards and just compute my plain text. You can't compute my plain text. Or at least nobody's found out how to reverse SHA-256. But you don't have to. You don't have to compute my plain text. What you can do is just take this hash function. SHA-256 is a standard hash function. Whether you use that website I just showed or you have some Python code that computes these, it's going to be the same exact value for the same input. It is an algorithm. It's going to be the same no matter what the implementation is, no matter how you implement it. So the attacker can just say, oh, you're using SHA-256? Okay, I got my SHA-256 right here, and I'm just going to guess every possible password I think you might have. And when I try a password and the hash that I get matches the hash that I got from you, well, I know what your password is. So we didn't break anything. We just used the hash function for its intended purpose and just did that until we got an input that matched the hash that we're trying to attack. Now I know your password. I can attack your password without attacking SHA-256. And since SHA-256 is nice and fast, I can make a lot of attempts per second. Lots of attempts. Especially if I have a nice, powerful GPU, I'm going to make lots and lots of attempts per second. Even worse, dictionary attack. Even worse than that, since I segued into it, I'm going to do this slide first. Even worse than that is dictionary attacks. So if you're generating your own passwords with your own human brain, there are a lot of patterns that we tend to follow. As humans, we like patterns. We're not going to randomly generate a purely random string as our password. We're going to follow some certain patterns. A lot of people like to think of common words and then maybe replace a few of the characters with common substitutions. Well, the attackers know this too, and they're not going to just guess purely random strings. They're going to use a dictionary attack, which attacks common passwords and common substitutions of certain letters. Password, where the S's are dollar signs, isn't a strong password. It's one of the first things an attacker is going to guess. The script that they have is going to look that one up right away. If you do have completely, purely random passwords, you can compute what's called the entropy of that password, which is the maximum number of guesses that somebody would have to make to guarantee that they get your password, even if the very last guess was your actual password. So for example, if you know somebody's password is plain text, lowercase letters only, and only one character, well, you only got to make 26 guesses. Just hash each letter in the alphabet. Look at the hashes and look at which one of those matches the hash, and you know that's the password. 26 guesses, worst case, and that password is cracked. If you have 2 characters, it's 26 squared. Significant increase up to 676, but nowhere near secure. If you allow uppercase and lowercase, 2704. And that's going to be the entropy. So if you can extend this, if you have 8 characters, if you follow the recommendations of a website, 8 characters where you have uppercase, lowercase, numerals, and special characters, and if you're generating a purely random password following those rules, you can compute how much entropy that password has. Generally, as a rule of thumb in security, we'll measure entropy in bits of entropy, which is the log base 2 of these values, because these values are going to get very large. We need huge values in order to actually be secure. So we say bits of entropy, the log base 2 of that, just to keep the numbers more manageable. And as a rule of thumb, we say if you got 80 bits of entropy, at that point, we'll call it secure, or at least secure. It's pretty secure at that. If you have, I shouldn't even put that in quotes. If you have true 80 bits of entropy and the attacker has to go through that entire 80 bits of entropy, you're secure. 2 to the 80 is a ridiculous number. If they're making trillions of guesses per second, if they're making a guess a nanosecond, well, I guess that'd be 1,000 guesses a nanosecond, right, if my math's right there. Even then, they're going to be working until the sun burns out to be able to crack your password. It's such a huge number that we say, okay, at 80 bits, we're secure. We're good. Can I run these numbers real quick? So if I have, say, an alphabet of size, 26 times 2 is our 52. We have the 10 numerals. And let's say we have 30 special characters. I don't remember how many there are, so I want to overestimate. If we have 30 special characters and we have an alphabet of size 92, and we're purely randomly generating an 8-character password, it's going to be this raised to the 8, which is this many possible passwords. And we're going to take the log base 2 of that, divided by, that doesn't work, does it? 92. It's such a simple equation, but I still got to pull out Wolfram alpha. 92 to the 8 log base 2. Oh my goodness. Log base 2 of 92 to the 8 is 52 bits of entropy. So if you're following the recommended rules that are pretty ubiquitous now at most sites, you're following those rules, and instead of just generating some patterned password that you're able to remember as a human with a human brain, you're going to be less than this. So even if you completely randomly generate your password and you have 8 characters, uppercase, lowercase, numbers, special characters, you still only have 52 bits of entropy. Not enough for us, in the security world, for us to say, that's secure. It's not even close to that 80 bits. This password can be cracked by a sophisticated hacker with enough resources, enough GPUs. If they got a cluster of machines all with powerful GPUs, they're cracking your password in not a ton of time. Like probably within a day. I'm guessing the numbers here, but within a day, they're cracking this password. The only saving grace is that they have to want to target you and use some resources on your password specifically. But you need to get a bit more. Like most websites aren't going to change those requirements because they're going to lose a lot of users. So it's probably going to be here to stay. And now we're seeing like two-factor authentication because people won't generate better passwords. But you need to get up to like 12. Luckily, this grows fast because it's the power of exponentiation. But at 12, now we're getting there. Now we're right at that boundary. If we have a length 13, completely, purely randomly generated password, we actually got some good security here. So you use your password manager. You have it generate at least length 13. I'd recommend just going up to like 15 or 20. It's purely randomly generated. You're not going to memorize it anyway. And have it generate those strong passwords for you. Yeah.
I actually saw a comic that recommends that easily, just a like just a letter, just like a easily memorized phrase, like a word is actually more advanced and like more rich and actually than like a random. Yes, exactly.
Yeah. It can't, I mean, the math's a little fuzzy, like a little blurred on this. If those characters are completely randomly generated, then yeah. But yeah, this would be better than, yeah, there's a lot of truth to this, yes. But the math, he's got to show more of his work on this one. If those words are completely randomly generated and generated from a large list of random words, then yeah, but you'd have to compute the entropy. And I think this does fall apart if the attacker knows you're using this strategy. So they can just add this to their attacks. Like this dictionary attack, it would just be a different attack and still crush the entropy of it, unfortunately. But if the attacker's not expecting this, then yeah, much better. Even in his math here, it's only 2 to the 44. Because the attacker's going to have more than 1,000 guesses per second. And there's always a relevant XKCD. There's a lot of truth to that as well. Always. That's not it. Oh, no. Where do we go? There's the lecture question. So we want entropy, and our target is 80. There's another big problem here. It was already mentioned in chat, so we better talk about it. Rainbow tables. So if I just have a hash, if we just have a hash of a password, a hash of a string, it's not going to be secure. There's an attack, what do I want to say? There's an attack called the rainbow table attack that's just going to absolutely crush those hashes. So the way rainbow table works, is instead of, okay, I have a hash of a password, I'm going to throw a bunch of guesses at it and see if I can get a hash that matches. What a rainbow table does is before they even get a hold of your hash, what the attacker is going to do is do a lot of pre-computation. So what they'll do is take some guess, some password as a guess, hash that to get a hash, apply some function to that hash to get it back to another reasonable password guess. Usually your hash is going to be some random garbage, something to get it down to like a shorter string that could be a potential password guess, some function that's going to convert it back to a reasonable guess. Hash that, apply the function again, hash that, apply the function again, hash that, apply the function, you get the idea. Do this, I don't know, billions, trillions, however many times they want, and then they're going to store the first guess and the last hash. And that's it. Those two things, the start and end of what we call a chain, and then store that. And then do it again. Do this again and again with all kinds of different chains, and store this one giant file with billions, trillions, however many chains you want, and then have this rainbow table, which can be up to gigabytes large of just storing the start and end of a chain. And then these rainbow tables get distributed. I haven't tried, but I'm sure you can just go download them. You can find them somewhere out there and just download these rainbow tables. And then when you have a hash that you want to attack, here's what you do. You take this hash, you apply the function to turn it into a guess, you hash that, apply the function, hash that, apply the function, hash that. You do that until the hash you have matches one of the ends of the chain. So now you know which chain contains the password you're attacking. You go to the start of that chain, you hash, you apply the function, you hash, you apply the function. You do that until you have the hash that you're attacking, and then you back up one step, and that's the password you're attacking. So you do a lot of pre-computation. These attackers can generate these rainbow tables for years before they even see your hash, store these very huge rainbow tables, so they're trading off some storage space as well, and then use that pre-computation and storage space to strongly leverage their attack, and then attack your password in potentially seconds or less. This is bad. We don't like this, because this is a huge vulnerability that can just destroy hashing completely. You generate a rainbow table for a specific hash function, and it just obliterates your hashes, can hack them almost immediately. Yeah. So it would have to attack a specific hash function. So like you would build a rainbow table for SHA-256, and then when you attack a database that's using SHA-256, that rainbow table works for every user in that database. And you can hash everybody's passwords. There's another attack, I didn't really talk about it, but if you have a database with a bunch of hashes, you can look at which hashes are the same. If you see the same hash like 50 times, that's probably the password of password. If you see any hash multiple times, it's going to be the weak passwords, and you can target those users, because you know they have weaker passwords that you're going to be able to brute force quickly. So rainbow tables and that attack where you're not attacking a specific user, you're attacking all users simultaneously, or even just every guess, you look up, okay, does this hash match any user? You can attack everybody at once. But no, you can't, because we're going to salt these things. We're going to salt these hashes, and those rainbow tables are going to be completely useless, and you have to attack one specific user at a time. Both of those attacks are completely destroyed by something called salting. With salting, what we're going to do is generate a random value when somebody registers. We're going to generate a random value. It can be a really long random value. Nobody has to know or care what these values are outside of our algorithms and database. We're going to append that value to the end of their password and then hash it. Then we're going to store that hash and the salt in the database associated with that user account. So the salt is going to be public information, not public information, but anybody compromising the database will know the salt. So it doesn't add any entropy, it doesn't add security in that sense. They'll know, the attacker will know the salt, and they can still just append that salt to their guesses and still brute force your password just the same as they would without the salt. That attack's fine, the dictionary attack is fine. Those are untouched, those can still be launched very successfully if you have a weak password. That's why we still talk about password strength in society. But those rainbow tables are done. So those rainbow tables were built on these chains where they have this function that's generating the next guess, the next guess, the next guess. Well, almost all of those next guesses will not end with that salt. It won't have the salt appended to it. So most of those guesses, almost every one of those guesses is completely useless. You could change your function to have that salt appended to it, but you wouldn't know that salt before you attack the database. So you can't pre-compute these things because you need to know the salt. You'd have to build a rainbow table with a specific salt in mind, and that's just not feasible. It's not going to happen that way. Not going to work. When you're coding this stuff, I didn't show, I guess I technically showed, but I didn't explain how to implement SHA-256 or anything. I don't expect you to either. bcrypt is your best friend here. You are allowed to use bcrypt and in fact encouraged to import bcrypt. It's a library that's going to handle your salting and hashing needs for you. And with bcrypt, you can do all the salting, hashing, checking passwords in 3 different method calls, 3 lines of code. Bcrypt will handle that all for you. And that's perfectly acceptable for the homework to just import bcrypt. In fact, if you're out there in the world and you're managing passwords, if you're in a position where you're doing that, bcrypt is the library that does this stuff. It's very handy. It's very well used, very extensively used out there, and has many good properties. Though, if you can avoid it, don't handle your own passwords. Just offload that to something else, because so many things can go wrong. So import bcrypt. It exists in any language I looked for it in, and including any language you are using on your homework. So when you register, you get username and password. Generate a salt, append the salt, compute the hash, store username, salt, and hash in the database. If you're using bcrypt, the hash will contain the salt. So you only have one value that has the salt and the hash. Authenticate, you get the username, password, you look up that salt and hash, append the salt, compute the hash, check if the hashes match. If they match, then you're good to go. bcrypt has one method that does all this for you. You give it the hash that you looked up and the plain text password that was inputted, and it'll pull the salt out of that hash value and do all the salting, hashing. It'll do all this for you. It's one of the cases where I just say use the library, because I don't want to teach you to get too lost in the weeds in authentication, because the more you build with authentication, the more chances you have a bug that won't cause any errors but will allow somebody to, if they compromise your database, to access everybody's passwords. That's bad news. Don't have those bugs, please. Yeah, very, very quickly. Yeah, anything you're allowed on the homework is allowed on the project. Everything is allowed on the project, with very few exceptions, actually. No. Nope. I never talked about that this semester. That's previous semesters. Previous semesters, you had to write reports if you used anything that wasn't allowed on the homework. This semester, it's those 3 reports, and that's it. I did mention all these, right? Hey, have a great day. I'll see you on Friday.